I think. There, okay. Now I am going to share my screen. And then I am going to, I have to be careful how much of the internet I get rid of. So let us, there we go, that's it. That's what I was looking for. But, there, okay. We are going to be working on quadratic word problems today. Since you have mastered factoring and all that stuff, we need to put it to work. Okay, so we have a right triangle here, and this side here, oh, it's going to let me mark on it. This side right here, this side, and this side, well, this side, are called legs, and this side is called the hypotenuse. Literally what that means is to hold below, held below. And if this were shaped like this, if this were shaped like this, with the right angle up here, then the hypotenuse would be here below. So it really is held below. But since another word, well, since hypo, nah, it doesn't. I mean, hypo just means beneath. So what can I do? In these days, though, it also means across from the right angle. If you were wondering what it means, that's what it means. And it's a pretty weird word, and weird words come from Greek. Now, that is not to say that Greek people are weird. It's just that their language can be weird. Okay, so now that we've discussed linguistics, let us get to work on math. Okay, so here's my triangle, a rough drawing of the triangle there. A very rough drawing, yes. And they're labeling this side X and this side 9 and this side X plus 1. And what we're going to be doing is finding out what X equals. So here we go. The relationship of the length of the sides of a right triangle are a squared plus b squared equals c squared. Okay, we've got enough now. So, usually, but not always, usually this vertical leg is A and the horizontal leg is B. And I think of that as being altitude and base. But regardless, I mean, you could get away with calling this B and this A if you wanted to. It doesn't matter. What matters is that this side is always C. You can call the two legs Charlie and Fred if you want to, but C is what the hypotenuse is and always will be. So remember that the hypotenuse, the slanty side, has got to be C. The other two don't matter as much, but in my world, I am going to let A be 9 and B be X and C be X plus 1. So here we go. We're going to have 9 squared plus X squared equals X plus 1 squared. So 81 plus X squared is going to equal X plus 1 times X plus 1. And then we're going to multiply these together. 81 plus X squared equals X squared plus 1X plus 1X plus 1 times 1 is 1. So we're going plus X squared equals X squared plus 2X plus 1. Okay, now we've got a quadratic equation. And when you've got a quadratic equation, you pull everything over to one side and set it equal to 0. But look what happens as soon as you subtract X squared from both sides. Both of the X squared zero out, and you don't have a quadratic equation anymore. You just have a normal linear equation. That is, you bring down the 2x, and you bring down the 1, the plus 1, and you bring down the 81, and look at that. This is just a normal equation now. You don't have to factor or anything. All you have to do is solve for x. So I will not add, but subtract 1 from both sides. That'll give me 80 on the left and 2x on the right. And then I'll divide by 2 and divide by 2, and boom. I get a 40. Which I think, I was going to say 40 feet. It's not, it's centimeters. Not that that really matters. It's a unit of length. So X is 40 centimeters. So now that we know what X is, we go back up here. X is 40. Wow, I drew that wrong, didn't I? You've got a really long base and a really short height. And then this is going to be X plus 1. So this is 40, and this is 9, and this is 40 plus 1, which is 41. And that was a real simple version of what you do with the Pythagorean theorem, which is what a squared plus b squared equals c squared is called. It's called the Pythagorean theorem. Pythagoras was an ancient Greek philosopher and mathematician. And he was doing great. He was the biggest name in Athens until he was forced to confront a triangle whose legs are both 1. We would call that an equilateral triangle, where both legs are the same length. Because when he used his theorem, he got 1 squared plus 1 squared equals c squared. So that's 1 plus 1 equals c squared. 2 equals c squared. And we solve this by taking the square root of both sides. And since we're talking about length, you know, normally I would put a plus or a minus there, but not when I'm talking about the length of something, because length doesn't have any meaning. So the answer was C equals, the hypotenuse equals the square root of 2. Well, Pythagoras didn't believe there was such a number as the square root of 2. So he went crazy over it. That's what most of the books say. He had a total mental breakdown over the square root of 2. Whatever happens, you can't let math be that important to you. Okay? That's Pythagoras. This is you. So we're not going to go crazy over the square root of 2. So trust me, you'll be doing more with the square root of 2. I mean, not the square root of 2. Let me make this bigger. There. With the Pythagorean theorem. Discussion? Okay. All right, this is hard, y'all. Stuff to remember. Consecutive integers. Number 2. Consecutive integers. We're going to talk about all the different consecutive. A different kind of consecutive integers. Consecutive integers. Consecutive. Consecutive integers are numbers like this. Integers. Let's do this. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and they keep going, right? They keep going in both directions. Those are consecutive integers. Consecutive means they follow one after another. All you have to do is add 1 to -5 to get to -4. You add 1 to -4 to get to -3. All you have to do is add 1 to get to the next number. These are consecutive integers. Now, consecutive even integers . You start with the consecutive integers and then you just pick out the even numbers. So -4, that's a really terrible arrow there. -2, 0 is neither even nor odd, so I'm going to come over here to 2 and 4 And so you have the even have numbers that look like this. These are consecutive even integers. Now there are also consecutive odd integers. And for consecutive odd integers, you start with all of the consecutive integers, and then you pick the odd numbers. So that would be -5, and -3, and -1, and 1, and 3, and 5. Of course, they just keep going. The consecutive odd integers would just keep going. And all of these have formulas. So here are the formulas for just consecutive integers. These guys up here on the top. Okay. And so we the smallest, middle, and largest. It's almost always X. It be X2. And here's an example. Suppose the smallest consecutive integer is 3. If I add 1 to 3, that would be 4. 3, because I 3 consecutive integers. Now, there are also formulas for consecutive odd and consecutive even integers. Consecutive odd integers. Okay, we're going to look at smallest, medium, largest again. Okay, again, I'm going to let the smallest one be X. The middle one is X plus 2. And the largest one is going to be X plus 4. Now, an example to prove it. Let's let the smallest, let's let it be 3. Let's let the smallest consecutive odd integer be 3. That means this is going to be 3, and this is going to be 3. Okay? Now, if I add 3 plus 2, if I add 2 to the X, I get 5. And if I add 4 to the X, I get 7. These are 3 consecutive odd integers. If I'm only looking at odd integers, these come right after the other. That's what consecutive means, coming one right after the other. They're in order, in other words. And the strangest thing is that for consecutive even integers, again, we could do smallest, middle, I say middle, but medium. Okay, well, I need an even number to be my smallest one. How about 2? Oh, well, I need the formulas first, and they're going to be exactly the same as for the odd, which is kind of strange, you have to admit, but it works. If I let my smallest even integer be 2, so that this is 2 and this is 2, then if I add 2 to x, I'll get 4. And if I add 4 to x, I'll get 6. And now these are even integers that are in order. They come right after each other. 2, 4, 6. You know, it's kind of like 2, 4, 6, 8. Who do we appreciate? Harkening back to high school. Okay, so 2, 4, 4, 6. These are, yeah, they're consecutive even integers. So you can have consecutive integers, consecutive even integers, consecutive odd integers. And now we are going to do a problem with consecutive even integers. And here are the answers, okay? 12, 14, 16. So now we know what the answers are, but pretend you don't know. If we have 3 consecutive even integers, then we are going to have smallest, medium, and largest. And this is number 2. Okay, I'm going to let the smallest one be x. I'm going to let the next one be x plus 2. And the next one be x plus 4. Now let's see what we're supposed to do with these. Find 3 consecutive even integers such that the square of the third is 60 more than the square of the second. Oh my goodness. Okay. All right. Let's read it again. The square of the third is going to be x plus 4 squared. This is the third one. I'm going to call this the third, this the second, and this is the first. So the square of the second, the square of the third is 60 more than the square of the second. All right, the square of the first is, equals is always is. The square of the first is 60 more than the square of the second. And now all I have to do is work these out. I'll find x, and that will give me the other two, as well as the first one. Okay, so x plus 4 is a binomial. It's squared, so I will say x plus 4 x plus 4 times x plus 4 equals x plus 2 times x plus 2 plus 60. All right, now I'm just going to work out this equation. This will be x squared plus 4x plus 4x plus 16 equals x squared plus 2x plus 2x plus 4 plus 60. Now I combine my like terms on each side of the equal sign before I start moving any of the terms. X squared plus 8x plus 16 equals x squared plus 4x plus 64. Okay, and that's what I've got right now. Okay. Well, normally, because it's a quadratic equation, I would pull everything over to the side, over to one side and set it equal to 0. However, as soon as I subtract the x squared term, I see that once again, the x squared terms are canceling out, zeroing out. So what that means is I have x plus 16 equals 4x plus 64. Now this is just a normal linear equation. I don't have to factor it, I don't have to do anything exciting to it. All I have to do is get my x terms together on one side of the equal sign and my constant terms together on the other side of the equal sign. So that's what I'm going to do. I'm going to subtract 4x from both sides. (8x minus 4x is 4x plus 16 equals 4x minus 4x plus 64. And now, in order to isolate my x term, I'm going to subtract 16 and subtract 16. So I will have 4x equals 14 minus 6 is 8, and 5 minus 1 is 4. So 4x equals 48. Then I will divide by 4 and divide by 4. So I get x equals 12. Cool. Now I know what x is at the top. And I say, okay, you are 12. And since x is 12, 12 plus 2 will be 14. And 12 plus 4 will be 16. And so my numbers should be 12, 14, and 16. And those are the answers, 12, 14, and 16. What you have to do this problem is you have to learn the difference between consecutive integers, consecutive odd integers, and consecutive even integers. And that means you learn and maybe recite to yourself, put them on flashcards, whatever you need to do to remember the formulas for consecutive integers. Let me erase the numbers there. X plus 1, and x plus 2. Consecutive odd integers. X plus 2, and x plus 4. And consecutive even integers. X plus 2, and x plus 4.
Miss Barbara,
yeah.
From?
I can't hear you.
Where did we get 60 from?
Okay. From there, yeah.
Oh.
Good question.
Okay.
Great. Any more questions? Any more discussion? These come up a lot with things like pages in a book, because the pages in the book are consecutively numbered. Those are consecutive integers. Okay. So let's go to, excuse me, to number 3. If I turn my stylus around correctly, then I'll be able to write. Number 3, we've got artwork here. Right there. A picture frame measures 18 centimeters by 30 centimeters. So here's the 30 centimeter side and 18 centimeter side. On the outside, and 364 square centimeters. 364 square centimeters of picture shows. So this picture in the frame shows 364 square centimeters. Find the width of the frame. All right, so the width of the frame is X. We need to find the width of the frame. So they've actually told us what we need to do. This is 30 centimeters. I'm going to make this bigger. It's such a good drawing. I hate to mess it up by trying to draw on it myself. There. On the outside, our picture frame is 30 centimeters here. But the frame is X centimeters wide and X centimeters wide. So that this side is going to be 30 centimeters minus X on this side and minus X on this side. So that this side right here is going to be 30 minus X minus X. So it's 30 minus 2X. So that's how they get their 30 minus 2X there. And the same for 18 minus 2X here. You've got something that was 18 centimeters wide. But the frame is X centimeters over here. And the frame is X centimeters over here. So this side is going to be the original 18 minus X on this side, and then minus X on this side. So that the actual picture frame, the actual picture, not the frame, but the picture itself that you see in the frame is going to be a rectangle that's 18 minus 2X wide and 30 minus 2X long. And we're given that the area of the picture is 364 centimeters. Centimeters squared. Or square centimeters. Just like square inches, square feet, square yards. Same idea. Okay, well, we know that this is a rectangle. And the area of a rectangle is length times width. The area we know is 364. The length is 30 minus 2X in parentheses, and the width is 18 minus 2X in parentheses. And we're going to multiply these. Okay, so 364, and now I am going to need my calculator. Calculator, there you are. Good. All right, so I'm going to take 30 and multiply it by 18 and multiply it by 2X. But I do not know what 30 times 18 is. Oh, come on, Barbara. Well, I don't know. 18 times 30, wimping out, is 540. So I've got 30 times 18 is 540. 30 times minus 2x is minus 60x. Now, negative 2x times 18 is going to be 2 times 8 is 36. So that will be minus 36x. And then minus 2x times minus 2x is plus 4x squared. So 60 minus 36, 10 minus 6 is 4, and 5 minus 3 is 2, that'll be 24. So we're going to have 364 equals 4x squared. Oh, you see how easy that is? Forget that. We've got negative 60 minus 36. That is, we already took away 60 x's. Now we're taking away 36 more. How many x's have we taken away? That's going to be 96 x's. Minus 96 x's plus 540. Now let me make sure that's true. Yes, it is. Yes, it is. Okay. So now this is a quadratic equation, and I do have to pull everything over to one side and set it equal to 0. And this time my x squared terms are not going to zero out. So minus 364 and minus 364. So that'll be 0. And over here, I bring down the 4x squared minus 96x. Okay, 10 minus 4 is 6. That becomes a 3, but I borrow 1 from the 5, which is a 4. So that'll be 13 minus 6 is 7. And 4 minus 3 is 1, but I'm going to make absolutely sure that's true. 6 plus 4 is 10, carry the 1. 14, carry the 1. 3 plus 2 is 5. Yes, it is true. Yay me, yay me. All right, now the great thing about an equation that's not necessarily true of an expression is, well, you have to try to factor out a GCF from both. And 4 will go into 4, 4 will go into 96, and 4 will go into 176. So let's see, 4 into 176 is 4, 16, bring down the 6, 4, 44. Okay, so here we go. We're going to pull out a GCF. Let's see, 4 into 96 is 2, 8, 9 minus 8 is 1, 16, 4, 24. So we're going to have 4. Well, let's take an extra step. We're going to have 4 times x squared minus 24 times 4 times x plus 4 times 44. Okay, so our GCF is going to be 4, and I surround the 4. I circle the 4. And then I factor it out as a GCF. And this helps me not rewrite the 4. So I'll have x squared minus 24x plus 44. Okay. Now I divide both, well, yeah, now this is the thing. Normally, if you were just factoring, your answer would be that, and then you would try to factor the quadratic part in the parentheses, but you would have already pulled out the 4. Now, when you've got an equation, you do the same thing to both sides of the equation. So I could, and I'm going to factor both sides by 4 because I can. And that gets rid of this extra 4. Remember, you cannot do that to a variable, but you can do it to a number. 0 divided by 4 is 0. So now I will have x squared minus 24x plus 44. Now let me make sure this is true. 4 into 176, that's 4, that's 16, 16, 4, yes. And 4, that's a 2, that's 9 minus 8 is 1, 16, 4, yes, that's true. Okay, now, I have to factor this. Let's hope I can find factors of 44 that add up to negative 24. Okay. Well, 44 equals, I'm going to do the positive ones first, just because they're easier. 2 times 22, 3, no, but 4 times 11, and I don't think any more than that. 2 and 22, whew, I was worried. All right, 2 plus 22 is 24, negative 2 times negative 22 is still positive 44. And negative plus negative 2, 22 is negative 24, which is what I'm looking for. So the two factors of 44 that add up to negative 24 are negative 2 and negative 22. And since there is now a 1 in front of the x squared, I can use the method if I want to of factoring, in which I split the x squared here and here, and then I take negative 2 and negative 22 and write them in here. Okay, now I set each factor equal to 0. I add 2 to both sides, plus 2 plus 2. So x equals positive 2. And plus 22 plus 22. Negative 22 plus 22 is 0. That leaves me with x on the left. 0 plus 22 is 22. And so, these are my two possible answers. Now I'm betting on 2 being the real answer, but we are now going to have to go back up here. And we are going to see which answer makes sense. In these kind of problems, usually only one of the answers makes sense. So 30 minus 2 times 2 is going to be 30 minus 4, which is 26. And 18 minus 2 times 2 is going to be 18 minus 4 is going to be 14. And 14 times 26 is 364. So 2 works. Now let's check out what would happen with 22. 18 minus 18 minus 2 times 22? Are you kidding me? I don't even have to try this. 8 is negative. Which makes no sense. How are you going to have a negative side of a rectangle? No, it won't work. So now we know that 22 is not one of our answers. The only answer to this is 2. So the width of the frame is going to be 2 centimeters. Let's go over what I did. We were told, and we were actually given this drawing, there's a rectangle that is 30 by 18. But it's got the middle cut out so you can put a picture in it. This is a picture frame. How much is cut out from here to here? In other words, what is the width of the picture frame? Well, we don't know, so we're calling it X. Now, we knew that this whole length was 30. This length inside is going to be the 30 minus this length minus this length. So that's where you get the 30 minus 2x. And the same here, we started off with 18 centimeters, but then we had to subtract this x and this x, which gave us 18 minus 2x. So we have a length that's 30 minus 2x and a width that's 18 minus 2x. And we're told ahead of time that the area of the picture that's showing is 364 centimeters. So this length times this width is 364 centimeters. So we were able to set up an equation. 364 equals 30 minus 2x times 18 minus 2x. We multiplied, we pulled 364 over and got 0 equals 4x squared minus 96x plus 176. Then we factored a GCF of 4 out of it and divided it out because we could. And then we factored what was left and found 2 answers, 2 and 22, and discovered 22 makes absolutely no sense given the context of the problem, but 2 does make sense. So we went with 2, and 2 centimeters is our answer. Okay. Discuss.
So 20. So
22 doesn't work.
Yeah, 22 doesn't work because it's a negative number, right?
Well, 22 is not negative, but it makes a negative number. Yeah, it would make this width be a negative number. And in fact, it would also make the length be negative. Because once you multiply it by 2, it's so big. 30 minus 44 would also be negative. So we have to just knock it out. Even if only one side got made negative, we would have to knock it out.
So what if one of our variables come out as a negative?
It would not if you set the problem up correctly.
Okay.
Which is handy. Okay. Good, more questions. But also, if one did come out negative, in the context of the problem, you would have to just throw it away immediately. Because we're talking about the length here. There's no such thing as a negative centimeter. Any more discussion or comments? Okay. Yep, 2. Okay, now we're talking about the width of a workbench. This is going to be another one like what we did. You've got a rectangular area. Okay, I in particular want to get to this problem. I think you can work this one now. It's very similar to the previous one, but this, the wire problem, yeah, the wire problem could be difficult. So I'm going to shrink it while I read it. Maybe that won't do any good. Okay, a wire is stretched from the ground to the top of an antenna tower. A wire is stretched from the ground to the top of an antenna tower. The wire is 17 feet long. The height of the tower is 7 feet greater than the distance D from the tower's base to the end of the wire. Find the distance D. Here's what they're talking about. I'm going to draw it here first. You've got a wire and you've got an antenna tower. You know how you see those. That's our antenna tower. Now, we've got a wire. And this wire is stretched from the top of the tower down to the ground. Now this distance from the base of the tower D and that is, oh, it's feet. It's all going to be in feet. The wire is 17 feet long. And the tower is 7 feet longer. So this is not drawn to scale. 7 feet longer than this distance right here. So this is going to be 7 plus D, but it would actually be better to say D plus 7. Okay, so I want to read it again. Down to the top of it, wire, 15 feet long. The height of the tower is 7 feet longer than, 7 feet greater than, the distance D from the tower's base to the end of the wire. Find the distance D and the height of the tower. So first we're going to find D, then we're going to add 7 to it, and you can see what their answers are right here. Okay. So I am now going to attempt to draw this correctly, or better anyway. And this is 17. And we hope, right, that this is a right angle. And so we're grateful I'm not an architect. And in trying to find the length of these sides, we have to use the Pythagorean theorem, which is a squared plus b squared equals c squared. The hypotenuse, the slanty side, is always c. And then this side, I'm going to let it be A, but I'm not going to try to stick it in there. This is side A, and this is side B. Our B equals D. It's kind of weird, but you kind of have to do that sometime. So here we go. I'm going to take D plus 7 and square it, plus D squared equals 17 squared. Okay, so that's how I'm going to set up this problem. So I will have D plus 7 times D plus 7 plus D squared equals 17 squared, which is 17 squared, 289. Okay, so this will be D squared plus 7D plus 7D plus 49 plus D squared equals 289. Okay, and over here, I'm going to combine my like terms. I have two like terms. I have a D squared and a D squared. I'm going to add them together, and then I've got a 7D and a 7D, and I'm going to add them together. So that will give me 2D squared plus 14D plus 49 equals 289. Then since this is a quadratic equation, I have to move 289 over so that I can put a 0 in that position. So I subtract 289 from both sides.